when I should use X and when I should use Y, because I cannot predict which one I should use. So this requires the use of a conditional statement. And it is also explained here how this works. But I think it's better if you look at a picture. Okay, so I'm going to look at this picture here. And in fact, what I can do is I can show this picture. It's a new tab. New tab. Nope, I don't want a new tab. I want to resize everything. Because what I want to do is to do it side by side. Application. Go. Magnify this a little bit. And then change this part back to here. All right. So now we have both the graphical representation and also the text representation. On the right-hand side, we have something that looks like a trail map. Okay, so look at this as a trail map, and it says basically, you're walking down from the north, okay, north to south. When you see a branch, because when you see this junction here, I'm going to use a mouse to indicate. When you see this junction here, there are two ways to proceed. You can either turn to, if you're coming from here, from that person's perspective, you're turning right, and this is turning left, okay? So you have to choose, because you cannot be at two places at the same time. You can only be at any place at any particular time. But to choose which way to go, what you will do is you look at this question here. This box represents a question that you have to answer. X greater than Y. Well, the question is really asking, is it true or is it false that X is greater than Y? So the answer to that question is either true or false, right? If the answer is true, then you follow the path that is labeled true to this side. If the answer is false, then you follow the other path that is labeled false, because when you follow this path here, the only thing you have to do is to make Z the same way as make Z the same as X. The other path will make Z the same as Y. But it doesn't matter which way you go, because they both have to merge at the end before going on to the next statement. Are we doing okay so far? Equating the text representation, which is on the left-hand side here, to the kind of graphical representation on the right-hand side. It's okay? Every time there's a branch, you have to answer a question. Depending on the answer to that question, you choose one path or the other one. But the key here is both paths have to merge at the end, and then exit, and then move on to the next statement if there is one. Is that okay? All right. So I'm going to get rid of this window here, because it's really just a picture of this one that is already in the text. All right. Let's go ahead and trace one, okay? Because in this class, we do a lot of tracing, which means we are actually executing programs, but without a computer. We are actually executing programs by hand, by understanding what happens to the variables as we go through the lines of an algorithm. So we'll go ahead and make an example out of this. So go to Calc, and I'm going to write my algorithm here first. Let's do something different, okay? I'll just say if X, let's start with something simple. If X is less than 5, then I'll say X gets X plus 2, else X gets X minus 2, and if. You don't have to copy this, because one, it is going to be recorded, and two, I'm saving this file to this folder. If someone reminds me to do it, I can upload it to the website. So this way, you don't have to spend too much time to write down everything on the projector. All right. So here's the algorithm. I want to find out, how we trace this kind of algorithm. So let's open a new window, so we can use another sheet to trace it. In fact, in this case, I'm going to trace it several times. I'll give you several test cases. Now, when you trace something that has a condition, I reserve one column and call it comments. Comments is really just for everything that is not a line number or the value of a variable. It's really just for me to leave a note to myself and remember, oh, what did I do here? Okay, but in this case, I need one column for comments. And then we have the usual line number, and we have one single variable in this case, which is x. The precondition, this time, it doesn't make any sense to make x equal to an unknown value. Because if x is an unknown value, I would not know whether the unknown value is less than 5 or not. Okay, so in this case, I cannot leave x to be unknown. I have to have a definite value in x for this algorithm to be traceable. So in this case, I can just use, let's say, 2, well, let's pick 3 as the initial value in x. In other words, this is an assumption. I'm assuming that x starts with a value of 3 before line 1 executes. And here comes line 1. Now, for those of you who don't like all these empty space, what you can do is you can select the columns that you want to resize, and then at the very edge here, when you slowly move the mouse until it turns into a double-sided arrow, double-click, and then what it will do is it's going to change the size of the columns that you have selected to just wide enough to for the content in those columns. So it's a pretty quick way to resize the column so it looks a little bit better. All right, so this is line 1. Now, line 1 is, it's not going to change x, right? Because all it's going to do is to evaluate the condition, which is the expression x is less than 5. And it will give me an answer of either true or false. So when you look at the effect on x, it doesn't change x itself at all, because x is going to remain with a value of 3 because we are not changing it. But when we look at the outcome of this line of executing line 1, it is very significant. So on the comments side, what I want to do, or what I want all of you to do in cases like this, is to say x is less than 5 is true. Okay, that's what we use that column for. Is for anything where the effect is not visible in the other columns, we want to leave comments to remember the outcome of executing that line. Is that okay? All right. Now that we know x is less than 5 is true, where should I go? We should go to line 2, right? Because according to the notes, according to this picture, if x is less than y is true, we follow this path here, which is the then path, or whatever is specified after then and before the else. So if I switch all the way back to the pseudocode, because this condition is true, I will execute whatever is specified after the keyword then, which is on line 2. What do we do on line 2? That's an assignment statement. We evaluate the right-hand side first. The right-hand side is x plus 2. X currently has a value of 3. 3 plus 2 is 5. So the entire right-hand side evaluates to 5. I use that to update the left-hand side, which is also x. So x is now updated to a value of 5. And then which line should we go?
Line 5.
Well, the correct answer is not line 5. Okay, it's actually post. We're done. We are all done already. Now let me explain why I have and if here. The reason why we have all these words, else and if and then, is to help us understand the text representation of the algorithm. Okay. The purpose of the word else is pretty clear. Okay. It is a separator. It separates what we should do when the condition is true from what we should do when the condition is false. So else is required because it is a separator. It separates what we should do depending on the outcome of the condition. And if is here because textually, visually, I want to be able to tell where is the end of this conditional statement. So end if is more like a closed parenthesis. Okay? So if end if is a closed parenthesis, which one do you think is the open parenthesis? The if, exactly. So when you look at this, if is the open parenthesis, and end if is the closed parenthesis. So this way we know, where it begins and also where it ends. Visual Basic is much like this, except I think end if is one word instead of end space if. But other than that, it uses the same construct to clearly have a beginning and an end for this construct. Okay. Are there any questions about this trace? This is the algorithm. This is one test case. I'm just saying, what if x equals 3? This is what's going to happen. Yep. What would a loop look like? A loop? Well, we'll get to that. We'll get to it. All right. So this is one test case. Let's try another test case. I'm going to use another sheet for the other test case. But before we go, I can be a little bit lazy and copy and paste certain portions of this. So this time, let's say x starts with a different value. Let's say it starts with a value of 10. Okay. Once again, we go to line 1. And once again, line 1 is only evaluating a condition. It does not change the value of x. So x will end up with the value of 10 after line 1 executes. On the other hand, it does have a very significant thing to remember, because I need to know whether the condition is true or false. X is less than 5 is false. Okay, so in this class, I just use F to represent false, because otherwise it takes up a lot more space in that column, and in column width is precious in this class. You guys will see later on, like half a semester later, that we'll be scrolling all over the place. Okay, we'll be running out of space, especially horizontal space. We'll be running out really quickly, and then we have to scroll left, right, and all kinds of stuff. Especially when I need to use a lower resolution and magnified text, because in the classroom setting, I want everybody to be able to see what is on the projector. All right, where do we go next? Line 4, exactly. We don't go to line 3, because line 3 is really just a line to separate the two portions of the code. It doesn't really do anything by itself, so we are actually going to line 4 right away. And line 4 is an assignment statement. We evaluate the right-hand side, which is x minus 2. X currently has a value of 10. 10 minus 2 is 8. And because this is an assignment, we change the left-hand side to this value, which turns out to be the same variable, which is x. So after line 4, we're done, because there's nothing after the the conditional statement. Are we doing okay so far with these two, what I would call test cases? It's okay? Yep, go ahead.
What would happen if x is equal to 5 in the precondition?
That's a good question. What if x equals 5 as the precondition? Okay, so let's go ahead and find it out. So here we have another test case, except x starts with a value of 5. So I'm going to remove all this stuff here, so we can just run the program the same way as we normally would. Once again, x is not updated, continues to have a value of 5. The real question is it true or is it false that x is less than 5? It's false. It is false. And so it will do about the same thing as in sheet 3, because it will go to line 4 in this case, because it is